All right, so we are starting confidence intervals this week. Um, this will be pretty exciting stuff. It's a new chapter, and it will help sort of set the idea for our next couple of chapters. So, confidence intervals. What are they? So, you're going to be able to tell yourself, I can interpret confidence levels, intervals in context, and I can interpret confidence levels in context. So imagine this. You want to find what percentage of the world is made of water. The only thing you have though is a globe. So you decide to yourself, I'm going to spin the globe and place my finger on a random spot and write down the number of times I land on land and land on water. And I'm just going to do this 40 times. And we end up with the water covering 0.7 of the world, or 70% of the world. So 70% of the time, we spun the globe and we landed on water. So how's this different from anything we've done before? Well, we don't actually know the true proportion of water on the earth. Like there's no stinking way we can like go into outer space, count up all the little water molecules and all the land in the world and like find out the true uh, proportion of water. I mean, even if you go on like Wikipedia, they can't give you like a there is exactly 0.63%. There is exactly 63% of the water covering the world. Like they're all just estimates. So what we actually have here is an estimation. It is not the true proportion of water on Earth. It's just like our best guess. This is our best estimate of what how much water there could be on Earth. And so our proportion in this case is an estimate. And so standard error. Well, we have a proportion estimate, but what about standard deviation? Well, we're going to estimate that, and um, when you estimate your standard deviation, it's called standard error. And standard error is equal to square root of p hat times q hat all over n. And remember, p hat is your proportion that you found, and q is 1 minus that proportion, and n is your sample size. So in our case, it would be the square root of 0.7 times 0.3 all divided by 40. We got 0.7 from, when we first spun the globe, and you got 0.3 from 1 minus 3, or 1 minus 7, and we got n because we did it 40 times. So put all that goodness into your calculator, and we end up with 0.0724 as our standard deviation, or our standard error. What is the purpose of a confidence interval? So the confidence interval allows us to provide an estimate of where the true proportion could be, and is measured by two standard errors from our estimated proportion. And so because two standard deviations from the mean is 95% of all possible proportion values. The same thing works for standard errors. When two standard errors from the mean captures 95% of our possible proportion estimates. So in this case, our confidence interval is between 0.55 and 0.845. And you get this from taking our mean of 0.7 and you're adding our standard error, which is 0.725, and you're subtracting it from our mean as well. And so we get a confidence interval of 0.55 and 0.84. So what the heck does that mean? How do you describe the confidence interval of the amount of water on Earth? So we have 0.55 and 0.845. So that means we are 95% confident that the true proportion of the amount of water on Earth is between 0.55 and 0.845. This is also called the one proportion Z interval. But you can also call it the confidence interval. And so it's really important that we understand that the confidence interval of 95% tells us that we are 95% 95% confident that the true proportion is between these two numbers. And that's how you would say it for any sort of question. Like any questions like that I would ask you on the AP exam, that would ask you, confidence interval, yada yada yada. You're going to be saying we are 95% confident that the true proportion is between 0.55 and 0.845. You're not 95% confident that the true mean is 0.7. You're not 95% confident that you're not going to say we are pretty sure that it's going to be 0.55 and 0.845. You are going to say you are 95% confident. Like you have to be this super specific. So, what does a 95% confidence interval really mean? So, because the intervals capture 95% of the possible proportions, 5% of the other proportions aren't in the interval. So, we have this sort of little picture here. You see that a lot, like, so that U right there represents the true proportion. Um, and you see that each one of these represents an interval, each of these little bars. Um, and so we are 95% confident that the interval indicates that 19 out of the 20 samples from the same population produce confidence intervals that contain the population parameter, which is again another way of saying the same thing. So a 95% confidence interval shows that every time we did this, if I spun the globe around the world one more time, 40 times, we are 95% confident that the interval, that other trial we just did contains the true proportion. So, maybe next time I won't get 0.7, I'll get 0.69 or I'll get 0.67. And so that'll give me a different proportion and that'll give me a different standard error. And so we are going to see that it's going to create for us a different interval, but we are 95% confident that of all the proportions we do, or all the confidence intervals that we could create, 95% of them will have this hypothetical true proportion in them. And what is margin of error and how is margin of error a balancing act? So the extent of the interval on either side of P is called the margin of error. And is a way to describe uncertainty in an estimate in estimating the population value. So basically, like obviously we don't know what the true population is. It's our best guess, and so it is just how our way of showing that it could be between, uh, you know, 84 and 55. And so that is our margin of error. And the more confident we want to be in our answer, the bigger the margin of error needs to be. The smaller the margin of error is, the less confident we will be. So it's like when you see, if you ever look at polls for presidents, I don't know, it's like, like I remember looking at, um, you know, looking at this year's election. I was looking at, some polls for Mitch McConnell. Mitch McConnell, had, I don't know, like 50% of the votes with a margin of error of 2. So they're saying that they are 95% confident that between 54 or 52 and 48 lies a true percentage of Kentuckians who want to vote for Mitch McConnell. So between those, and if you want to, like the bigger the margin of error is, like, oh, between 0 and 100% lies the true proportion of people who want to vote for Mitch McConnell. Like obviously, you are very confident that, like I would be very confident that it would be between 0 and 100%, like anybody would. But if they said that exactly, like exactly down to the very, hundredth decimal, that 50% of the people would vote for Mitch McConnell. Like, you can't be really confident in that because the interval is so small, or the margin of error is so small. So, the bigger the margin error, the more confident we can be. And the smaller the margin errors, the less confident we can be. So, a couple examples. In April and May 2011, the Yale Project on Climate Change Communication and George Mason University Center for Climate Change interviewed 1,010 U.S. adults about America's global warming beliefs and attitudes. Question: it is standard among pollsters to use a 95% confidence level unless otherwise stated. Given that, what do these researchers mean by their confidence interval in this context? So think about it. Refer to how I worded a 95% confidence interval. Answer it. Pause the video if you need to. But the answer to this is if this polling were done repeatedly, 95% of all random samples would yield confidence intervals that contain the true proportion of all US adults who believe that there's a lot of disagreement among scientists about global warming. So, again, 95%, if I did this a bunch of times, 95% of all those confidence intervals of all the times I just did them would contain the true proportion of all US adults who believe such and such. Example 2. In a April 2011 Yale George Mason poll of 1,010 US adults asking questions about current topics reported a margin of error of 3%. It is a convention among pollsters to use a 95% confidence level and to report the worst case margin of error. Based on p equals 0.5, how did the researchers calculate their margin of error? So again, remember, margin of error equals the distance from our mean, and a 95% confidence level, that distance is going to be equal to 2 standard errors from that mean. So think about that. Think about what formula we would use and answer the question. So again, we would use standard error because standard error shows the distance from the mean. And so 0.5 times 0.5 all divided by 1010 equals 0.0157. And a 95% confidence level, it's 2 standard errors from the mean. So that's going to be equal to 0.031, or they're pretty, or what the organization said. Their margin of error was 0.03. So that is how they got that margin of error. Alrighty. I'll see you guys later. Chill out.